Hey guys, here's my Module 1 practice making thermometers and using them as an experiment. So the question that I set to find out, and I really geared this around my third graders, so they're 8 and 9-year-old. So I wanted to do something that I could do in their class with them relating to science and obviously STEM areas. So the question I came up with was, does the color of the bottle affect how much heat energy is created, and what color conducts the most heat? Obviously, we as adults know that darker colored things attract more heat and lighter colored things reflect heat. However, 8 and 9-year-olds may not know that. So that's the question I came up with pertaining to my third grade classroom. So here are some examples of me painting the bottles. I chose to paint them two dark colors, and I explained down below in the design process template. And I also have a picture of my two bottles after 5 minutes. So you can see the black bottle, the balloon is slightly more inflated than the other one. They were both hot to touch because they both have black balloons on them. But like I said, the black bottle is definitely more inflated than the red bottle. And this is them after an hour, which you didn't see too much difference in the inflation from an hour to a half hour. I think that the red bottle may have blew up a little bit more, but I'm not sure that the black bottle conducted too much more heat in that extra half hour time span. So here is my engineering design process template, and I kind of filled it out again as if I were to do this in third grade. So I'll kind of explain how I did it, but I also would make a few changes if I was doing this in my classroom. So first, identifying the problem, and that goes back to my question. Does the color of the bottle affect how much heat energy is created? What color conducts the most heat? Some limitations were depending on the day or time, the heat conducted would be a variable. So if you're doing this over a certain number of days in school, you might want to take into consideration that the temperature is probably going to be different colors each day, or different temperatures, not colors, each day. And then the paint colors was also a variable. For me, I just chose two dark paint colors just for monetary sake. But if I were doing this in a classroom, I would have different groups do different colors, and then they would all compare them to see what colors conducted the most heat. And then the thickness of the paint applied would also be a variable. So maybe some paint you put two coats on, one bottle you put one coat on. So making sure that they had the same amount of paint on them. So then we went to explore, and this would be when we would research what others have done and discover what materials are available. So then I went and I researched how colors conduct heat differently. Like I said, we as adults know that darker colors attract the heat and lighter colors reflect heat, but my third graders probably would not know that. So I would have them research this, and I would have them research what dark colors would be best to use, and from there we would go ahead to the design. So personally, I found the top two colors that conducted heat. So I found a dark red and I found the black. And I painted to the two bottles to those colors, and I attached a black balloon on top of each of them. Again, in my third grade classroom, I would have each group pick a different color that was dark based on their research, and then we would go from there. And I personally did a black balloon on top of each of them to keep it consistent. I'm not sure, that might be another variable though in the experiment, if I had a red balloon on top of the red one versus a black balloon on top of the black one. So I think as long as you were to keep that consistent throughout the whole experiment, then it would be okay. So then you would want to go ahead and create your experiment. So like I showed you in the pictures, I painted one bottle black and one purple, and I attached the balloons on them. So then try it out. And then I let the bottles sit outside for the same amount of time. So personally, I checked them after 30 minutes and after an hour. With my kids, I would probably do something pretty similar to that. And I would see then what bottle's balloon had more heat energy in it. So which balloon was bigger. And for me, it happened to be the black bottle still. So I'm really wondering after that, then going back to making it better, I'm really wondering, is there any color that can conduct more heat than black, since black is one of the darkest colors. And again, to make it better, I would obviously include more paint colors in my classroom, that thickness of paint, and make sure it's applied equally. And then time, just making sure that each group would be setting their balloon outside in the temperature for the same amount of time. But personally, after doing this, I was really curious to see if is there another color that beats black, because I feel like in every time black always conducts the most heat. So that's just something interesting that I wonder about. And then looking at the Vasquez rubric, I went ahead and highlighted some of the STEM practices that this lesson in my classroom would go with. So with science and engineering, they kind of hit in the same categories, so I'm just going to talk about them all at once. So developing and using models. Obviously, these students were developing the models. They were choosing the colors that would attract the most heat, and then they were using the models and they painted them, put the balloon on top, and then they would actually set them out in the sun. Planning and carrying out investigations. Again, they planned this. They went into the research and they found what colors conduct the most heat, and then they carried out the investigation. Engaging in argument from evidence. I think that this is interesting because since they went ahead and researched what colors conduct the most heat, they are technically arguing to that point to the research. So is what the research says true? Are these dark colors conducting more heat than the light colors? Technology-wise, I did not really see one category that it mainly hit. The only thing I thought of with technology was somehow bringing in how, like, what color roof would be the best roof to put solar panels on, or something like that, to incorporate technology into today's day and age. And then lastly, math, making sense of problems and persevering in solving them. So really asking the kids, why would dark colors conduct more heat, and have them figure that out and describe that. And then constructing viable arguments and critiquing the reasoning of others. Like I said, I'd have them do this in groups. So they would have to be able to stand up for their argument of what color they think would conduct the most heat, and also be able to explain that to other groups. So I think it'd be a good way for them to construct a viable argument in terms of their own team's findings. So overall, that was my experiment. I actually really enjoyed creating these thermometers, and I could definitely see myself using this in my third grade classroom. So I think that that is really cool.